Okay, so we're going to look at number 6 here. What is a unit rate and what is its purpose? So before we go into unit rate, let's just remember what a rate is. We have some down here. So like dollars per gallon. So anything per anything else, the per means division. And I think of it like dollars per gallons. So that's a rate. What is a unit rate then? So the idea is that unit is singular, not plural. So it's a rate where you don't have plural things on the bottom. It's just 1 gallon. So instead of dollars over gallons, it would be dollars for per 1 gallon. That's a unit rate. And sometimes we write it like this, however many dollars over 1 gallon, or sometimes we write however many dollars per gallon. We can write a unit rate that way. Some examples of unit rates. I could have $20, right, per 1 gallon. I could have 45 feet per 1 hour. These are all unit rates. Okay, unit rate examples. Anything where it's over 1, that's the key. 1 unit. Some examples of not unit rates. Are like the ones we have below here. I'll just use these. $20 for 4 gallons. It's because this is not just 1. It's a unit rate is only when the denominator is 1. We have 120 inches for 6 hours. All right, so that's what a unit rate is. The denominator is 1. And what's its purpose? It will make it easier, I should say the purpose, we'll do a star here, of a unit rate is to make it easier to compare rates. We'll see when we start doing some examples. We'll see what I mean by this. If everything has the same denominator of 1, I can compare those rates. So for number 7, these are not unit rates. Number 7A is not a unit rate because of the 4 gallons. If I want to turn it into a unit rate, I know it's going to be over 1 gallon. And the way that I can get the numerator is I actually do the division here. I'm going to do the 20 like with the numbers, 20 divided by the 4. All right, and that's going to be my numerator. So 20 divided by 4 is 5. And it was dollars on top. So instead of writing dollars, I'll put the dollar sign. So it's $5 for every 1 gallon. It makes it easier to compare now. If I was trying to compare the price of gasoline at another gas station, I know at this station, if I filled up 4 gallons and it cost me $20, I know it's $5 per 1 gallon. Maybe like at another station, a different day, I put in 13 gallons, right? And it was like, I don't know, $68. How would I compare like between the $20 for 4 gallons and the $68 for 13 gallons? It's too hard to compare. So if I do the unit rate, the $20 for 4 gallons comes down to $5 per 1 gallon. Now I can compare it to the 68 because I can also do that. So I'm going to do the I know if I want the unit rate, I'm going to turn it into 1 gallon. And then if I want the number up top, I'm going to actually do the 68 divided by the 13. So I'll use decimals over here. 68 divided by 13. It tells me it's like 5.23. So I know it's going to be $5.23 per gallon. So which one was the cheaper? It might have not been obvious at first, but the place where it was $20 for 4 gallons. That ends up being cheaper because once I make them into unit rates, right? These both are unit rates. I can compare them. I can just compare the numerators now and see which one was smaller. So the $5 per gallon is smaller, so I'm going to go to that gas station. It's cheaper. All right, let's convert this one here into a unit rate. So if it's a unit rate, I know it's going to be per 1 hour, and then I just have to do however many inches. So how do I get the inches on top? I actually do the division, the 120 divided by 6. 120 divided by 6. I get 20, so that'll be 20 inches per hour. That's the unit rate, $5 per 1 gallon. Over here, I have 35 donuts in 2 classes. So that means for 1 class, how many donuts do I need to buy per class? So I could do, I know I'm going to have a number of donuts. Whoops, I put a U in there. I'm spelling it all old school. I can do the division, the 35 divided by the 2. 35 divided by 2. 17.5 donuts per class. All right, so those are my unit rates. Remember, you'll also see unit rates written like this. $5 per gallon. That implies, notice I don't have the S there. It's not gallons, so that implies that it's per 1 gallon. That's what makes it a unit rate. This one would be 20 inches per hour. That would be a heck of a snowstorm. This one here is going to be 17.5 donuts per class. Okay, let's move along into unit rate. Plot the given point on the coordinate plane, and then use the slope to find the second point on the line. Connect the points with a straight line. So I'm not going to, that's kind of a review again of what we've been doing. Maybe I'll do one with you. So I'll graph the point -2, 6. So I go left 2, 1, 2, and then up 6, 1, 2, 3, 4, 5, 6. There's the point -2, 6. Let me erase my counting. And then it has a slope of -3. So from there I go down 1, 2, 3, and then over to the right 1, because I think of that as like over 1. So here's my new point. I draw the line. Oh, and they want the coordinates of that second point. So this point right here, that new one I came up with, its coordinates are -1, 3. Because from the origin to get to it, I go left 1, so there's my -1, and up 3. So those are the coordinates of that point. All right, I'm not going to do B. You can do that in class for practice. I want to just focus kind of on unit rates and rates here on this. So number 9, Sam and Kim went on a hike. The graph below shows their situation. Find the slope of Kim's hike. Always include units of measure. Write Kim's slope as a unit rate. So we will go through this one since it talks about unit rate. So find the slope of Kim's hike. So Kim started here at 0, 0, and the next place that it kind of crosses nice is right there. So to find her slope, I got to do rise and run. So it looks like she rises +3 and then runs +4. Now, what are the units? On the rise, it's distance in miles. So it's going to be a +3 miles. I'll use MI for miles. And the time is in hours, so it'll take her 4 hours. So remember, it's rise over run, so it's going to be 3 miles every 4 hours. Before we get into her unit rate, let's go find the slope of Sam's hike. Sam also starts at 0, 0, and it looks like we hit a nice point right there. So Sam, we go up 1, so it's +1 in miles. And then we go right 2, so it's +2 in hours. All right, yeah, that's fine. So this was in miles, right, because we went up 1 and then right 2. So his rate is 1 mile every 2 hours. So the question is, who's hiking faster or who's hiking slower? So you need a unit rate. This would be kind of how fast they're hiking, 3 miles in 4 hours versus 1 mile in 2 hours. So we can't compare them because the denominators are not the same. It just kind of goes back to some math, like if you try to compare just straight numbers, 3/4 and 1/2, it's hard to compare them. I mean, I know these numbers we kind of know because it's like 0.75 and 0.5, but I could give you harder examples that it would be tougher for you to compare. And it's hard to compare fractions when their denominators are different. So I want to just highlight that's the point of the unit rate. So let's convert them both into unit rates. So if I'm going to make Kim's slope as a unit rate, I know it's going to be 1 hour on the bottom. Let me write out the word. And on top, it's going to be miles. So I'm going to actually do the division. 3 divided by 4. 3 divided by 4. I get 0.75. That is the unit rate for Kim, 0.75 miles per hour. It could be written as the fraction, or we can write it as how I just said it, per hour. That means the same thing. Let's go with Sam's hike. I know it's, oh, sorry, down here I want to do the unit rate. I know it's going to be per 1 hour. That's what makes it a unit rate. And I know up top it's going to be some amount of miles. We have to actually do this division, the 1 divided by the 2. And yeah, we want to change it to the decimal. So that is 0.5 miles per hour, or in 1 hour. Or we can write it, as I said, 0.5 miles per 1 hour. By making the denominator per 1 hour, it's now pretty easy to compare their speeds. That's how far Kim goes in 1 hour. That's how far, Sam goes in 1 hour. So now I can tell who's going faster, okay, because I have the denominator of 1 and they're easily comparable. So who's hiking at a faster speed, Kim or Sam? Explain how you know by looking at the graph and by using the numbers. So you can look at the straight numbers to compare, and we'll talk about it in class. I want to see what your answers are in class. You're going to do this on your own. Or we can look at the graph and try to figure that out. And again, let's talk about it in class and see the connection between both ways that we do it.